PVC plastic is typically quite rigid and brittle when it doesn't contain a plasticizer. When it contains a plasticizer, it becomes soft and malleable, and it can be used for things such as gloves. In this video, we'll be extracting phthalate-based plasticizers from vinyl gloves and then reacting it to form phthalic acid. The phthalic acid will then be converted into nearly pure phthalic anhydride by sublimation. Phthalic anhydride is an extremely useful organic molecule, and in a future video I'll use it to make phenolphthalein. Also, over the course of several videos, I'll convert it to phthalimide, then to anthranilic acid, and finally to methyl anthranilate. Methyl anthranilate is an imitation grape flavor that's used in lots of different candies and foods, and it's used as the main flavor additive in grape Kool-Aid. For this experiment, I used 50 grams of vinyl gloves, 10 grams of sodium hydroxide, and 25 milliliters of concentrated hydrochloric acid. Not all gloves contain phthalate-based plasticizers, and you might have to shop around or try this experiment on several different brands of gloves before you find one that contains the right plasticizer. 250 milliliters of isopropyl was added to a round bottom flask. A sock-slit extractor is then loaded with some cotton, followed by 50 grams of cut-up vinyl gloves. The gloves were cut up into small pieces using a pair of scissors. A condenser was added to the top of the sock-slit extractor and the water lines were attached. The extraction was allowed to run for 2 hours. The molecule we're interested in extracting is the plasticizer in the gloves, and it's called DEHP. For this step, you really don't need to use a sock-slit extractor, but it is a much more efficient method. As an alternative, you could simply add the gloves to a beaker containing isopropyl, boil it, and filter off the gloves afterwards. The sock-slit extractor allows for efficient and continuous extraction of the plasticizer using fresh solvent. To the right is a little cartoon of a sock-slit extractor in action that I got from Wikipedia. If you want a better explanation on how one works, you can watch my video on how to extract capsaicinoids where I use a sock-slit extractor and I explain it in more detail. In short though, hot solvent travels up the sidearm and collects in the sock-slit extractor, and once the solvent reaches a certain height, it all drains back down into the round bottom. After 2 hours, the sock-slit extractor is removed and 10 grams of sodium hydroxide dissolved in 250 milliliters of water was added. This step is a base ester hydrolysis where the ester bonds in the red box are hydrolyzed. This forms the salt form of our desired phthalic acid product as well as alcohols. To complete the ester hydrolysis reaction, we're going to need to add some heat, and to do this we bring our solution to a reflux. I only refluxed it for about an hour, but it's probably better to reflux it for around 2 to 3 hours. After the reflux, the reaction flask was allowed to cool and it separated into 2 layers. The lower aqueous layer contains our desired product disodium phthalate. We don't need the upper layer, so try to decant as much of it as possible without losing any of the aqueous layer. The remainder of the mixture was then transferred to a separatory funnel, and then it was allowed to stand to let the layers separate. After pouring it in, the aqueous layer might be cloudy like it is here, but you should wait until it clears up as much as possible. The aqueous layer might, however, remain slightly cloudy, but that's okay. Once the lower layer had cleared up as much as possible, it was drained into a beaker. To this was added 25 milliliters of concentrated hydrochloric acid to regenerate the phthalic acid from its salt. The solution was stirred thoroughly and then it was placed into a freezer to allow crystals to form. Once the solution reached about 0 degrees Celsius, it was removed from the freezer. At the bottom, some crude phthalic acid crystals have formed. The water was then decanted off. On a hot plate, the crude phthalic acid was dried and the remaining water was boiled off. By heating the phthalic acid, we can convert it to phthalic anhydride, which will then sublimate. When it was noticed that phthalic anhydride was starting to sublimate off, a round bottom flask containing water was placed on top of the beaker. As the phthalic acid is heated, it melts, decomposes as phthalic anhydride, which then itself is sublimated off. The sublimated phthalic anhydride collects at the bottom of the round bottom flask and the side of the beaker. Only 30 seconds to a minute is required on high heat, and then the beaker and the round bottom flask are removed from heat. It is very important to allow for the beaker to cool and the phthalic acid to re-solidify. If you do not wait for it to cool, when the round bottom flask is removed, phthalic anhydride dust will fly out of the beaker. Once the phthalic acid is re-solidified, the round bottom flask is removed. In the beaker, we can see some nice, clean, white phthalic anhydride crystals have formed. Using a scupula, the crystals are removed and effort is made not to touch any of the phthalic acid at the bottom of the beaker. The nice and nearly pure phthalic anhydride crystals are then placed inside a dram vial. This process is then repeated several times until no more phthalic anhydride is sublimated off. The final yield was nearly 4 grams of pure phthalic anhydride. Shown here is only about 1 gram of the total. The crystals are very fluffy and it looks like a lot more than it really is. This is just to show you how brittle the gloves are after the plasticizer is being removed. Stretching and tearing forces cause the pieces to break apart quite easily.